Hi guys, this is Mrs. Mindy, and today I'm going to show you how to read chemical formulas, which is really important in knowing what kinds of compounds you're talking about. So we talked about this a long time ago. A chemical formula is a way of writing what a molecule is. So instead of drawing some kind of little diagram um, to say what we want, which is that this is a water molecule, we can just write down what kinds of atoms are in it and how many. And that's what the chemical formula tells you. It tells you that there is one oxygen molecule, just that's right here, and two hydrogen molecules. So this is a little bit different than what you may be used to in math, because this number that sort of hangs down off of the element symbol, that goes with the symbol before it. Okay, so this is saying two hydrogens, and if there's no number, it's just like in math. If there's a variable, if there's no number at all, then that means that there's one of these. Okay. I mean, we just don't write a one because scientists don't like to do anything they don't have to do, to be clear. Okay. So two hydrogens, one oxygen. There are some things to be careful about when you're looking at how to draw these chemical formulas, how to write the chemical formulas. And if you have been sloppy in your life in writing things out, now is the time to stop it because it is going to mess you up. Okay. Um, you have probably noticed that in the periodic table, some elements have one letter and some have two letters. The second letter is always lowercase. Okay. And that's really important. It will mess you up if you aren't clear with this. Okay, so an example of how you could be messed up is that big C little s, CS, is cesium. So that's one element. But big C big S means something totally different. So that's one carbon and one sulfur. Okay, so the elements, how you know that a new element is starting is there's a capital letter. So I know that this is a new element starting out here. The lowercase means that these two go together and that is one thing. Okay, so it's really important that you are really clear on that. Okay, another thing that can possibly mess you up, and this is the worst thing year after year, is lowercase l and uppercase I look almost exactly the same when they are written. And I will always try to use a font that at least shows a difference between them. So, like big C, little l is chlorine, big C, big I is one carbon and one iodine. Okay, so when I myself am doing this, I draw a lowercase l in cursive. So it looks like this. And so that I can totally tell that those two go together and that that's not this you can't tell because there's no even little markings on here. So the thing to look out for, and I'm sorry, this is just how it is with our language. See how this I there this little thing on the side goes out onto two sides. And if it's a lowercase l, it only goes on one side. Do you see that? Okay. Remember later that I warned you about this because this catches people every year. Okay. Chlorine. Now, most of the time, you are going to see chlorine a lot more just because it's really reactive than you're going to see something like this. But just to know. Okay. So we're going to practice reading these simple molecular formulas. Okay, these chemical formulas. And remember, the number goes with the element before. So water is H2O because it's two H's and one O. And this is important for you to be able to know what this is. This is like the recipe for that molecule. Okay, in ammonia, looking at this, it is one N, one nitrogen, and three H's, three hydrogens. Okay, the three goes with that. All right, I hope this is becoming clear. Hydrogen peroxide is going to be two hydrogens and two oxygens. And carbon dioxide is one carbon because there's no number here and two O's. Okay, and sometimes people will ask, well, why didn't they just put it before the element? And it's because that means something else. That means something else that we're going to talk more about later. because then anything ahead of this is going to refer to the whole molecule. And just, you don't have to know that now, but just to know that there's a reason why it's like that. Okay. Now, tricky. Some groups of atoms repeat in a molecule. So, and because scientists are basically lazy, they want to do things the easiest way possible. So that whole group goes in parentheses. And so if there are multiple of this group, you just put the whole thing in parentheses and then put a little 2 hanging off this whole thing. Okay, so this means 2 of everything inside the parentheses. 2 times the N, 2 times the 3 O's. Okay? So just to show this in another way, because different people get this in different ways, there's 1 Ca in the molecule, and there are 2 NO3 groups. Okay? And this is a group that just comes up a lot. So it kind of helps when you get used to it, you see like what is actually happening in the molecule. So if you are counting these up, you're counting this twice. So 1N plus 1N is 2N. So there are 2 N's in here. And 3 oxygens plus 3 oxygens is 6 oxygens. Okay. You can do this the way that you kind of would in math, where you multiply the number on the outside by the parentheses. So 2 times 1N is 2N's. 2 times 3 O's is 6 O's. Okay? Hope that's clear. Let's go through some examples. Oh, that's just showing, in case you're wondering, what that actually looks like. This group, and this just group comes up over and over in your chemical life. Okay, so let's practice reading these formulas. How many of these in each element? So here's a PB, that's lead. There's no number there, so there's 1 PB. Okay, 1 PB. Going inside the parentheses, and remember in the parentheses, you should always be looking for the number outside the parentheses. So inside the parentheses, there's 1 N and 3 O's, right? But because of the parentheses, 2 times 1 N is 2 N's, 2 nitrogens. 2 times 3 oxygens is 6 oxygens, okay? So that's 2 nitrogens, 6 oxygens on that one. All right, SN is 10. And there's only 1 tin because there's no number here. So 1 SN. And then here is your next element is Cr, chromium. So you're kind of doing 2 things as you do this. You've got to know what the elements are, like where one element starts and where it stops, and then how many there are of it, okay? So Cr is chromium. It's inside the parentheses. So 2 times 1 chromium inside the parentheses is 2 chromiums, okay? And 2 times 4 oxygens within the parentheses, 2 times 4 is 8. So that's 8 oxygens, okay? So you've got 1 tin, 1 SN, 2 chromiums, and 8 oxygens. All right. For this one now, don't be frightened, because the parentheses are just at the beginning, and it doesn't matter, it acts the same way. Okay. So there's 2 ammonium groups. So inside the parentheses, there's 1 N and 4 H's, but then it's the parentheses. So you got to multiply everything by this 2. Okay, so 2 times 1 N is 2 N's. 2 times 8 H's, I'm sorry, 2, I said it wrong. 2 times 4 H's is 8 H's. Okay, C, this C has no number by it. Okay, so it's just 1 C. And then for the O's, there's just 3 O's, okay? So this number does not affect anything except what's in the parentheses, okay? Here down here, there's Mg, so a magnesium. There's 1 magnesium because there's no number here, okay? Inside these parentheses, it's our old friend again. It's NO3, so there's 1 inside the parentheses, 1 N and 3, but this number is on the outside. So it's 2 times 1 N is 2 N's. 2 times 3 oxygens is 6 oxygens. Okay? Starting to get this? Okay, good. I will see you next time. You're going to try this in your assignment.